So here we have the platform for the ARM-powered Windows 10 laptop. So hello, so who are you?
So my name's Andrew. I work for marketing for Qualcomm, and we're showing the mobile PC demo here.
And there's a big event yesterday, the Microsoft keynote, and it was announced that Asus, HP, Lenovo are making amazing devices with the Snapdragon and Windows 10.
That's right. So and what we're showing here is we have, for the first time, Windows 10 running on Snapdragon 835 to give people a real feel for the actual experience they can expect on those devices.
So right here is just a demonstration of approximately what the difference might be. This would be an Intel device. It's nearly double the size compared to a Snapdragon 835. It's just much more optimized, more compact.
Well, what we're doing is we're going from discrete components, what you see in the competing platforms, to the SoC that Snapdragon has. So things like the modem and GPS and other components in there, like a Wi-Fi. Those are all built into the SoC instead of being discrete components. So it takes up much less space on the PCB, allowing for what we're estimating about 30% reduction in PCB size. The big advantage there is thinner, lighter devices and bigger batteries for longer battery life.
So these are under construction right now, being optimized in very, very thin laptops that are gonna consume less power, run long on a battery.
So the design that we're talking about, or the designs that we're talking about with our partners are the thin and light fanless designs. These would be 2-in-1s and convertibles, detachables, that type of device.
And you're running Windows 10 right now. It's a full Windows, and you're running on a development device. This is the Snapdragon 835 development device, right?
Right. This is one of our engineering platforms. We use it for demos periodically when we need to connect for the modem demos, but this is just one of our development platforms that we're using for this demo.
And so this connection to the LTE, so you can demonstrate that this is going to be LTE, gigabit LTE.
Gigabit LTE, yep.
So let's check it out. This looks like Windows. It's Windows.
It looks like Windows because it is Windows. So we'll go through just some of the activities here. We're doing some productivity, and we're showing the ecosystem. Do some video streaming to show the connectivity.
You have all these apps basically open at the same time.
These are open right now.
So multitasking.
Yep.
All the UI of Windows 10 is fully speed up, optimized. You're still working. I mean, it's coming by the end of the year, right?
Yeah. That's when we're expecting first launches. So this is all. And it's like I say, it's simple. This is Windows on ARM, but this is regular Office applications. I have all of my capabilities. There's essentially nothing here that is different from any Office application and experience.
So here you're doing some of the advanced stuff that is possible to do in Excel, and this is the x86 version of Excel. It's not an ARM optimized version.
Right. Yeah. This is Win32 application running through emulation. So as I go through this, you can pay close attention and see that it's very high performance, even though we're running on emulation.
So this emulator has got to be pretty amazing and impressive how it's done. Like there's all kinds of optimizations to not use too much processing power, but make things fast.
I mean, there's always going to be a little bit of a performance hit when you're running on emulation. If you want a lot of details about exactly how that emulation works, Microsoft released on their Channel 9 video channel, they have a video that shows in significant detail the compile process, and they talk a lot about the emulation.
So they demonstrate how you can recompile for Windows Universal, right? When it's Universal, then it's fully ARM optimized.
Right, when you do Universal, it'll run natively on ARM, so you don't even have to worry about that emulation.
This is the PowerPoint. You copied from Excel to PowerPoint?
Copied from Excel to PowerPoint. We can pull up multiple windows, so I can bring in Word. We can copy from Word into PowerPoint. So I'm just building a presentation here just to show some of the capabilities. With Word and PowerPoint, it's exactly the same as it is with Excel. This is just Office. There's nothing special or different here. It has all the functionality that people already depend on, and we're just running it on Snapdragon.
So this is full Windows 10. It's not Windows 10s.
Correct.
It's not only universal apps.
Correct.
It's any app.
Any application. Well, any Universal or Win32 applications. Right now, the current release of the emulation doesn't support the Win64 applications. Currently. Yeah,
but I mean, most of the apps are Win32, right?
Right.
On Windows.
I mean, almost all applications are Win32, or they have 64-bit and 32-bit versions, and so then you just do the 32-bit version.
And you could just download any .x and just install.
Yeah, so actually we'll show in just a second here. So I'm just finishing up that productivity. I just emailed the file to myself. But now let's go out to the internet, and we'll go find a file here. Actually, we'll just do this 7-zip here.
So you just download?
So I'm just going to download the 32-bit x86 application. Now, 7-zip, and this application was created with no knowledge of Windows on ARM or Snapdragon and Windows collaborating. So we just download and install.
It runs even the security scan like Windows would?
Still runs security scan because it is Windows.
So it's got all this anti-malware stuff running in the background, all the stuff they usually do?
All of the tools and capabilities of Windows are in this, because again, it's Windows. So I've installed it.
And then it's a real app. You can do everything with it.
Yep. It's here.
It's going to be very, very interesting to see how the performance is with all kinds of apps. Hopefully later you'll be showing more and more apps.
Oh, definitely. Yeah, as we get closer to commercialization with our partners, there's definitely going to be a lot more getting out in the wild about different testing and playing around.
Actually, several months ago, Microsoft even showed Photoshop.
Yep.
It was a full Photoshop, real Photoshop, and they were in the video saying, "Look, it's full speed."
Yeah, well, they applied, I think, a radial blur to a photo. Now, this is not the type of device that you're going to want to be your production photographer device, right? This is if you're out in the field and you're taking some photos and you want to edit them before you send them somewhere, you can do that. But it's really, we're focusing on the web browsing, the productivity, the video streaming. Those are the things that most people do most of the time with their devices. Those are going to be amazing experiences. Everything else is going to be entirely possible and usable and doable.
Hopefully.
Yeah.
I'm hoping even something like video editing.
Yeah. Well, we'll see. We'll see. I have not tested video editing yet. We'll see.
And some basic photo editing. I just do a few things in GIMP. GIMP would be nice. It's going to be interesting. Later, I mean, soon enough, people are going to be able to maybe even run benchmarks and see how you perform or...
Well, I mean, definitely, there's no stopping people from running benchmarks. The thing that we want people to focus on, though, is really the experience. So when you run your applications, does it work well? Does it do exactly what you need it to do? Is the performance good? That's what we want people to focus on. Like you saw, I was running Excel, everything's working perfectly, regardless of the fact that it's running through emulation. Yeah, you could run a benchmark and say, well, through emulation, it's not working as well. But you don't see that. What you experience is a great running app.
So right now there's Edge browser. This is an ARM-optimized Edge browser, right?
This case, let's actually see here. Is this running Win32?
So you got
Edge is actually emulation as well.
It's also emulation, even the browser.
Yeah.
So, for example, if you would have Chrome and you did install Chrome on this one, right? Then it's X32, is X86.
Yeah, it would be
for now.
X86. Yeah.
But who knows? They could be optimizing
They could do a universal app, yeah.
Because they have ARM Chromebooks, so I guess they already have some software that could just port over or something.
I'm sure. I mean, the once these devices start getting out there, the whole ecosystem is going to start, optimizing their own applications for it.
I can imagine that maybe you'd have some stats, what's most in demand, what people are doing, and try to encourage the developers to optimize those a little bit to the ARM, so you don't have to emulate forever. Maybe some of them eventually come over to Universal. That's what Microsoft wants.
Well, yeah, definitely. They want their ecosystem to be optimized for a perfect experience on every platform. So they're going to be pushing more and more developers, or working with more and more developers to get them onto those universal apps.
Can we see a YouTube video?
Yeah.
Because, for example, even if this is the x86 browser and you're running YouTube video without hitch, that's pretty cool.
Yeah.
So it just shows that all the stuff that goes on in there's a lot of hardware acceleration in a browser, a huge amount, and still you're able to run it. You can do video, you can do all the HTML5 stuff in a browser.
And this is also showing a little bit of that gigabit LTE side of things as well. So this is streaming 1080p. You can see how quickly when I click around in here, we can reload. Now this is actually bottlenecked at 100 megabits per second because of our internet connection here. But if I go into, let's say I want to download the movie instead of streaming it, I can go to our local area network where we'll actually see the full speed of a gigabit LTE connection.
This is local?
Yeah, this is local server, but I'm through our gigabit LTE connection. Just because right now gigabit LTE is not deployed, So we can get that end-to-end gigabit LTE.
45 megabyte per second.
Megabytes. So yeah, so we're seeing here is high 300s megabits per second. This is a good number for us to be able to show because it's not that theoretical maximum of that 972 megabits per second or something that we get. It's actual numbers that someone might actually see while doing a download on gigabit LTE network.
This could be the biggest deal for the whole ISP telecom industry to get on board with this and get large display productivity on their LTE networks. So
yeah,
that's,
I mean,
that's
getting more devices, doing more content. It depends on each carrier's business model on why exactly they're incentivized to do it. Sometimes it's just adding more devices and more data, and that gets them more revenue. Other times it's a loyalty play. The more devices that you get on there, the less likely you are to change to a different carrier or something. So there are many reasons for it, but yes, carriers are quite excited about it.
The carrier should basically say, hey, which phone do you want? You pick an 835 high-end phone. Which laptop you want? You can pick Asus, HP, Lenovo. Sign a contract 2 years, you get both of them subsidized.
That's up to them.
I think that would be a great business model. You would be selling millions of these if you and this built-in LTE is a big deal. That actually for the consumer,
well,
that's the speed.
I mean, gigabit LTE is a big deal on whether you're talking about cellular or mobile PC. For the mobile PC, though, we think it's a particularly big shift in how you approach these devices, because it's not just, well, do I have this in local storage, or is my computer capable of doing this? Instead, you've got a really fast connection to the cloud, and the cloud can then become what you're capable of. So if it's stored out in the cloud, it doesn't really matter whether I have it here or there. I can get it here as soon as I need it. And it doesn't really matter if I'm capable of doing this here. If there's a capability out in the cloud, I can take full advantage of it from anywhere at incredible data speeds.
So it could include a whole bunch of, like, terabyte on OneDrive. I think they should do that. Like, include a whole bunch of cloud storage. Have fun on Google Drive as much as you want. It just feels like local.
Yeah,
if all your files are right
the
there.
idea. And as we go further over the coming years and get into 5G, it'll be even more like that. That's where they talk about maybe local storage will become a thing of the past. I mean, we'll see how it all goes, but those are definite possibilities.
But of course, it also has huge Wi-Fi speed, right? It's the fast Wi-Fi.
No, extremely. It has.
It's not AD.
835 actually has AD built in. It
ultimately
could be AD, depending on the design that
that's
our customers
gigabit Wi-Fi.
That's multi-gigabit Wi-Fi.
Multi-gigabit Wi-Fi.
Right, because AC can do over a gigabit, but yeah, AD is multi-gigabit. That's where you're getting 4 gigabits per second of
like many of the ISPs, they actually recommend you. They want you to roam, so they want all their customers to have a second SSID at home, and so you can easily auto-connect on a million Wi-Fi hotspots in each country. Like they want to promote that. That would be a way to use it easily. You just walk around. You might go on Wi-Fi, not be on LTE all the time. And still have
there's a lot of different approaches to how they manage the networks, whether you're going through an internet backhaul or the cellular backhaul. But ultimately, we want to support everything.
Amazon should also they have unlimited storage with Amazon Drive, which is pretty awesome. And so this is a 10 nanometer chip. I don't think Intel does any 10 nanometers yet, right?
Nothing.
They're on 14.
Not yet. Yeah.
So that gives you an advantage too. And this is 8-core, big little.
Yeah, 8-core Big Little, you can see here, we were showing that. And this is actually something else important, because Big Little is something new to the Windows side of things. And so this is a new level of efficiency in the processing for a Windows machine. And when you compare this to an x86, you can see I've parked some of my big cores as I've scaled down my activity.
There's 4 big and 4 small?
Yeah, these are the 4 little right here, and then the 4 big right here. And this number right here, we haven't released exactly what our peak CPU speed is going to be, but this is talking about the peak speed of Core 0, which is one of our little cores.
It's not a smartphone, it's a bigger device. You could be cranking up the gigahertz, but then maybe without it being an issue.
No, we'll be announcing the speed.
More careful,
there
right?
are definitely fewer thermal constraints on these larger devices, so that's definitely a possibility. We're going to get everything we can out of it, and we'll be announcing the speed at some point in the future as well. Nice.
So this is basically it is the fastest ARM processor in the world, right? You're pretty proud to maybe. I'm just guessing, but it's a 10 nanometer octa-core. It's one of the fastest in the world.
It's an extremely advanced processor. And we expect this to be a big advantage in Windows, also not just because of what you're seeing here, but actually when you go into, say, standby, we'll have what you would call connected standby, where you can be syncing your data, you can have Cortana active, and you can be getting giving voice commands and waking up the device. You get that instant on capability that you have on a phone, but this is all while consuming far less power than what you would see on an x86 processor in regular standby, when all it's doing is maintaining state of apps. We expect to see 4 to 5 times less power consumption in ours in standby while doing all of that background processing on these devices. So that's a new thing for Windows as well.
I'd like to have all 3 of the assistants. You can just call each of them what you want. You say, hey, okay, Google, or hello, Echo, and the other, hi, Cortana. And then it wakes up, the screen just, or there could be LED light, there could be a second display. They have all these options. You can have a little display on the back with like showing how many emails you've got, like you need to get back to work, something that you've never seen in a laptop before. If they want. Okay,
yeah,
I say.
We'll see what they do. We'll see. We're going to enable everything.
Nice, and this big little is it's very interesting to see how it gets super optimized in Windows 10. Mm-hmm. Because actually, I would guess most people, even when they have a huge Intel device, they rarely use like 10% of the performance that's there.
Sure,
they just have lots of wasted. I mean, if
you look at the CPU usage, really you use the most cores at the highest peaks when you're loading an app or when you're booting up. And then when you're actually using it, it's actually quite variable. We say it's like bursty. It's like network traffic. It goes up and then it goes down. But most of the time, you see situations like this. Let's say I'm browsing to a web page. I browse to the page, things spike up, and then while I'm reading the page, it goes down. And then it spikes up when I load a different app, and then it goes down while I actually use it. That's what you typically see. So being able to scale like we can with the big little is a big advantage for efficiency.
I would think even a video editor most of the time doesn't do, but just when you need to render something, it goes through a big peak. Yeah. And hopefully you get to optimize all the peaks people want. Like if they want some specific peaks, maybe you can maybe the emulator will be perfect on day one, or maybe you keep optimizing it, keep improving it.
There will always be continuous improvement and optimization. That's just the nature of the industry. We'll definitely be supporting that.